Now, slope. This is section 7.4. The slope is defined as the change in y over the change in x, which is y2 minus y1 over x2 minus x1. y2 is just saying the second y coordinate in the second point minus the y coordinate in the first point over the second coordinate in the x point in the second point and the x coordinate in the first point. And that also is the same as rise over run. It's a very similar concept. Rise over run means you rise from the first point up to and you run to get to the second point. So this is a positively sloped line, 2 over 2. 2 over 2 equals 1. We use the symbol m to describe slope. M equals 1. This is a positively sloped line because it goes off to the right, like an airplane taking off. Negatively sloped lines will go the other direction, that way. And slopes that are 0 will be flat, like my arm, flat, just like you're bicycling along Santa Monica, let's say. It's all flat. And straight up and down, like this, is like a cliff that you're trying to climb, but you can't. And that is undefined slope. Why is that undefined? Because when you're looking at rise over run, we're talking about the change in y over the change in x. When it's totally up and down, there is no change in x. And therefore, the bottom of this fraction is 0, and that's undefined. So we're going to talk about that in a little second here. Okay, so the slope for a vertical line, these are special cases. The slope for a vertical line, what's happening in this one? What's the change or the rise in the vertical line?
It's going straight up.
There, it's going right up, right? The rise is infinite, really. No, the rise is not 0. The rise is infinite. Does everybody know what infinity is?
It's like a never.
It's like a never-ending story.
It looks like a weird shape.
Yeah, it looks a little weird. But what's the run? The important thing about this question is that the run doesn't move right or left.
It's 0.
It's 0. But in fractions, are you allowed to have 0 on the bottom? No.
So
Undefined.
It's
Undefined.
It's undefined.
Right. And now how about the horizontal line? So the rise is what? The rise is 0. There's no rise. And the run is infinite. So now, in this case, what is 0 over anything? Okay, 0. So in this case, the slope is equal to 0. So that's a careful and subtle point that, again, people mess up, is the difference between a vertical line and the slope of a horizontal line. The slope of a vertical line is undefined. The slope of a horizontal line is 0. And it's important to understand why. Not just memorize it, but actually understand why that is. Because if you just memorize it, it's likely that you'll forget. So please understand, the rise is infinite on this one, but the run is 0, and you can't have 0 on the bottom of a fraction. That's why it's undefined. In this case, the 0 is on the top of the fraction because the rise doesn't happen. And so, but 0 over infinity, the run is infinite. It can be any number. And therefore, this is okay. 0 over infinity, 0 divided by any number is fine, equal to 0. Okay? So, any questions on that?
Okay, homework page 316, numbers 2 through 54 evens. Also page 321, numbers 2 through 30 evens.
Good, and we'll say it again. These are evens. Do the best you can. If you need to work out the odd problems to try to get a handle on it, then please do. The answers are in the book. The other thing is there are examples in the book you should read and use your notes from today's class. 316, number 2 through 54 evens. Page 321, 2 through 30 evens. And there'll be a quiz on Friday on everything we're doing in graph. Okay, so on page 321 of your homework assignment, number 6 reads like this. Graph the line going through 4, 1 and -2, -3 and find the slope. We've got 2 points, you can graph them. That's one way to find the slope. And this question asks you to graph it. So Glenn has done a good job at putting 4, 1, 1, 2, 3, 4 and up 1. They're right there. So that's 4, 1. And when you're graphing and using to find slope, it's good to put the points down. A -2, -3, -2 and -3 is right here. Notice I'm drawing the points in because we're going to use them. So that's important. -2, -3 is here. 4, 1 is there. We're going to try the rise over run method here. And so we start at the bottom and we ask ourselves, where do we go? Do we go up or down to get up to here? Well, you tell me. Up. We go up. We go up this amount. Okay, up to here, and we run across to there. We form a triangle. This is rise. How many do we rise? We rise from -3, right here, to 1. So how far do we rise?
4.
Right, we rise up 4. So how far do we run?
6.
Right, we run 6. We go from -2, 1, 2, 3, 4, 5, 6. We run right 6. So in our fraction for slope, m equals rise over run equals what? No, rise is what? 4. Yeah, exactly. My bad. It's equal to 2/3.
Yes.
Sorry, Hilly.
2/3.
So we rise 4, we run 6, and we reduce the fraction from 4/6 to 2/3. Now the other method for doing this is, even if you didn't have to graph it, is to go y2 minus y1 over x2 minus x1. What's that?
Not negative for me. Like that.
Okay, well let's try that. First of all, you have to label what this is. This is x1, y1, and this is x2, y2. Okay? x1, y1, and x2, y2. So why is it that? Because this little 1 means the first point. X, y, but the first one. The little 1 is the first point. The second point is x2, y2. That's what that little 2 is for. So x1, y1, x2, y2. When we're plugging them in here, what do we do? Does anybody know? What's y2?
Oh, it's
Y2 is 3.
-3. Be careful, that's what people make mistakes on. y1 is? Negative, oh yeah, -1, that's right. And then x2 is equal to?
-2.
And then minus what?
4.
Good stuff. So it's -3 minus 1, which is -4 over -6, and that equals...
You cancel the negative.
Yes, of course, always negative divided by a negative, okay? So you get the same thing as you got the other way. They're two different methods, and this one they ask you to actually graph it and then do the rise over run method. Sometimes they'll just say find the slope. Given 2 points, find the slope. And then you can use the y2 minus y1 over x2 minus x1 method. It depends.
They're really bloopers, though.
Well, they're not
It's funny.
bloopers.
They're just
That's
kinda
true.
sad.
They're sad, aren't they?
They are.
They are sad.
No, it is funny.
They're funny and sad at the both. They're
not.
They're not funny. They're just sad.
It's sad.
They're outlandish. No, they're
Yeah,
just
that's what
sad.
they are.
It actually is really funny.
Okay, whatever. There we go. Okay?
Okay.
That's the line y equals x. Thank you so much, Ben.
Woo! Benny boy!
Yeah.
Benny boy!
Yeah.
Benny boy!
Yeah. This has been a Banana Apple production. Do your homework, kids.